Okay, last chapter, and actually save the best for last. This is usually the chapter that students like the most because, for the most part, exes don't show up, except possibly ex-boyfriends here. Dealing with probabilities. And this one is dealing with what's called permutations and combinations. So let's go ahead and look at this introduction. Jenny is taking her 9 best friends to the movie and is worried about how she was going to have them sit behind each other. Since Bobby is dating Amy's ex-boyfriend, Ginny is mad at Maddie for cutting her hair like hers, you know, the typical teenage drama. So question 1 is, how many different ways can the 10 of them sit? Okay, well, let's think about the seats. So we have 10 different seats here. 4, 5, 6, 7, 8, 9, 10 seats. So how many girls can sit in that first one? There's 10 different options of girls sitting in that first one. We choose one of those girls who's sitting in the second one. We now have 9 different options. Now that we have 2 girls sat, we have 8 different options. And you see the pattern? We're going to multiply all the way down until we only have one option at the end there. Okay, this is called a permutation because it deals with arrangement. Okay, one way that we could put this in the calculator is exactly like this. Another way is using one of the tools that it has called a factorial button. So there is, since these are all exciting, we use an exclamation point. This is called 10 factorial. And what it's going to do is it's going to do exactly this. It's going to arrange it 10 times 9 times 8 times 7 and so on. So go ahead and get out your calculator. And I'm going to show you where that button is. Okay, first thing that we have to do is tell the calculator we're dealing with 10. And then we want to go to that math button. We have to go all the way over to PRB, which deals with probability, because this is a probability chapter. And number 4 is a factorial. So if we hit 4, again, this is saying 10 factorial. It's saying how many ways can we arrange 10 items. That's how many ways. Okay, 3,628,800. So 3,628,000, whatever that last number was, 800. Okay, so a permutation deals with arrangement. Factorial is arranging all 10 of those straight away. Okay, let's look at this next one. After the movies, the girls played Truth or Dare, and Jenny chose the truth. The girls asked Jenny to name her 4 best friends in order of importance. Okay, this one's a little bit different than that first one because now instead of having 10 girls that we're focusing on, we actually have 4 out of the 9 friends that she had. So we are looking at 4 arrangements out of 9. Okay, so how many girls could she say for that first one? First off, we are dealing with 4 friends, so there's 4 slots for these friends. How many names could she say for that first one? 9. How many names can she say for the second one? 8, 7, and 6. Okay, this is still called a permutation because we're still dealing with arrangements. The calculator, though, is not going to see this as a factorial because we're not taking 9 factorial. We are stopping at 6 because these are the arrangements that we have. So there is a button in there that deals with permutation. And what it does is it has the 9 over here and the 4 over here. Okay, so this is the total possible. And this deals with how many we are arranging. Okay, so we could just plug this into the calculator, which we're going to do. Let's go ahead and do that. 9 times 8 times 7 times 6, 3,024. Okay, later we might be dealing with some bigger numbers. So again, I'm going to show you how to put this into the calculator. We have 9 friends. We are arranging 4 of them. So we go ahead and hit that 9. We have to go back to math, still dealing with probabilities. But look at 2. 2 deals with permutation. Okay, so we're going to hit 2, and we know that we are arranging 4 of our friends. 3024. Okay, so that P deals with permutations. N is how many we are choosing out of. 4 are the ones that we are going to arrange. So how many combinations could she say? 3024. Talk about some good teenage drama there. Okay, this next problem is a little bit different because let's go ahead and read it and I'll explain why. The girls realized that that was a pretty hard task, naming the friends in order, having a permutation there. So what they decided is she could just state her top 4 best friends in no particular order. So how many different combinations could she say now? Notice that this is called a combination. And this is when order is not important. Okay, so we're going to write this a little bit different. We're going to first off look at how many possibilities she has with all 9 of them. So we are going to put out that 9 factorial. Okay, and then we're going to get rid of the ones that we know we don't need. We don't need these bottom 5 because we're just looking at the top 4. So we're going to divide out 5, 4, 3, 2, and 1. Okay, we don't need those. All right, we're also going to look at these 4 best friends. They said we don't have to order them anymore. So we're also going to get rid of them. Okay, so looking at this, we actually can do some simplifying. We can get rid of 4, 3, 2, 1. Again, we didn't have to look at a permutation, so we got rid of the permutation there. Looks like we can simplify a 5. We can maybe simplify a 4 times 2 is an 8. 6 we can simplify down to a 2. So we got rid of all of our denominator. Kind of helps us out. So we have a 9 times a 7 times a 2. 126. So there's 126 ways that she can tell her friends who her top 4 best friends are. So a little bit easier on her. Okay, that's a pretty crazy formula that we just dealt with. Again, calculator understands this with their own formula, and it deals with the combination. Still dealing with this, that we have 9 total possible friends, and we are just choosing 4 of them. And notice how I'm going to say this, how many we are choosing. We are not arranging anymore, we are choosing. So let's go back into that calculator. We said 126. We are going to tell the calculator we have 9. Math, over to probability, we are just choosing, so combination 3, we are choosing 4 of those 9, and we get 126. So this is the only time that I'm going to show you how to set these up differently than using the calculator. But I did show you that the calculator shows both ways are right, okay, but we understand their formula and how it works in the calculator. So what we are dealing with, permutations arranging, combinations just choosing. All right, go ahead and get out your notes and vocab for this section. Okay, the objectives of this section are to determine those combinations and those permutations, understanding that new vocab. Okay, I stated it, but here it is again. When objects in a sample space are arranged so that order is important, each possible arrangement is called a permutation. They do a good job showing the examples here. Okay, they also show you how that factorial works, but again, we remember that if we hit the number, so if we hit 9, and then we go to math, and we go to PRB, 4 is that factorial button. All right, let's look at this. A travel agency is planning a European vacation package. How many ways can the agency arrange the 5 cities along the tour? So we see that word arrange. We see 5 cities. We realize that we are dealing with 5 factorial. And we know that there's 2 different ways to plug that into the calculator. But I'm going to go ahead and use our factorial button to get used to it. I'm going to plug in 5, and I'm going to go to math, over to probability, and I'm going to ask it to find 5 factorial. there are 120 different ways that we can arrange those cities. Okay, so that's just arrangement. That's not 5 out of the 3 city or 3 of the 5 cities. It's just arranging. So that is just a factorial. Still a permutation, but a pretty simple one using factorials. Go ahead and try that with guided practice 1. Okay, seeing that we are arranging 6 friends, we have 6 factorial, which is 720 different ways. Okay, next part here deals with that permutations. That again, suppose Angie's coach has 5 players in mind for the first 3 spots. So this is where we're choosing the 3 out of the 5. They do show the permutation that we talked about in the introduction. We didn't see it as a formula, but here it is right here. Notice how they do P and R. In our calculator, it's actually written as N and R. So total objects, total number, and the number we are arranging. Okay, so we have seen all of this. We have just not seen it in a formula as fancy as that. And we didn't see these as N and R, but we understand how to set this up. Okay, so with that in mind, the librarian is placing 6 of 10 magazines in a school showcase. How many ways can she arrange the magazines in the case? So we know that we're arranging. We know we are dealing with a permutation. The total number of magazines is 10. We are arranging 6. How do we put that in the calculator? We have to tell them that we are starting with 10. Math probability. Permutations is 2. And we want to arrange 6 out of those 10. How many different ways? 151,200. She has a fun job to do. Okay, so permutations arranging 6 of the 10. Go ahead and try guided practice 2. Okay, so again, we are arranging 5 of the 8, so that is a permutation of 6,720 ways. So permutations arranging. Combinations, remember, this is a selection of objects in which order is not important. It is called a combination. They give a pretty good example of how that's different than permutation. If you remember, when we looked at this formula, we looked at all of our possible ways of the friends. Okay, we got rid of the 5 that we didn't need, but then we also got rid of the arrangement because on the top we did arrange them, so we had to cancel out that arrangement part and then cancel out the combination part that we didn't have to take in consideration. So this formula is a little bit confusing. Again, remember, that's why we understand in the calculator, this is the total number, and this is the number we are choosing. I'm not saying go ahead and totally disregard this formula, but again, calculator understands it. So let's go ahead and use our resources. Okay, here we go. Marquez works part-time at a local department store. His manager asked him to make a display using 5 different styles of shirts from 8 available styles. How many ways can Marcus choose the shirts? Again, choose and combinations go together. So I know that we don't have to order those shirts. I am ordering 5 of the 8. And with that, I'm going to ask the calculator. I have 8 to choose from. This is a probability combination, so I'm going to hit 3 of 5. So 5 of 3 choices, I have 56 ways that I can choose. Okay, we could use that formula and get the same. We can use the calculator and get the same. So go ahead and try guided practice 3. Okay, this problem gets a little wordy because it says they can choose from 4 roses, 6 carnations, and 8 tulips. It says if all of the flowers are different, in how many ways can 4 flowers be chosen? Well, how many flowers can they choose from? They can choose from 18 different types of flowers. We are taking 4 of those 18. We are choosing, so we know this is a combination. So we have 3,060 ways to deal with. Okay, so again, I keep saying that choosing word, that arrangement word, to understand the difference between combination and permutations, because when we have problems written together, we have to figure out which formula we're going to use. So again, part of the difficulty in learning permutations and combinations is distinguishing between them. So remember that order matters with permutations. Okay, and we're supposed to identify each situation as a permutation or a combination. So that's the only thing we're going to write down as our answer. It says a playlist of songs on a digital media player is being played so that songs do not repeat. And how many ways can the songs be played? Okay, notice they say the word ways. Okay, how many ways can I arrange the songs on my digital media player? So arranging and ways are going to be permutations, because the songs are in order. B. Amy orders an ice cream cone with 3 different flavors. There are 26 possible flavors. How many different sets of 3 flavors can she choose? Or there's that clue word right there, choose. It doesn't matter what order those flavors are. She's just choosing them, so we know that that's a combination. So look for those clue words to figure out what we are dealing with so we know which formula to use. Go ahead and try guided practice 4A. Okay, the clue words here, seating chart, a range of students. So since we are arranging them, that's a permutation. The 10 athletes enter a race, the top 3 finishers move on to the next round. It's the top 3. It doesn't matter if you were first, second, or third. As long as you were one of those 3, you move on, so it's a combination. Okay, now we're going to look at that as probabilities. Here we were just looking at the amount of ways, but now we're going to look at probabilities. It says a Spanish club is forming 2 teams for the International Festival. Rebecca and Lydia are among the 9 who volunteered to lead a team. If the advisor assigns positions at random, what is the probability that Rebecca is chosen to lead the food team and Lydia is chosen to lead the tickets team? Okay, so we're forming 2 teams and we're taking 2 out of those 9. But this is a permutation because we are ordering them. Okay, these 2 teams, what are we looking at? Food and tickets. Okay, since arrangement does matter, that one person could be food, one person could be tickets, and vice versa, this is a permutation. So I'm dealing with a permutation. Rebecca and Lydia are 2. So we are choosing those 2 out of the 9 students will lead those teams. Okay, so let's go ahead and look at what this permutation is to see how many possible outcomes there are. So again, 9, permutation 2. There's 72 possible ways that these kids could be ordered. That they could choose the 2 leaders. Okay, now let's focus on Rebecca and Lydia. Rebecca and Lydia want to be one of those possible 72. So looking at this as a probability, we're going to find the outcome when Rebecca is food and Lydia is tickets versus total outcome. Okay, well, how many ways could Rebecca be food and Lydia be tickets? Just one. There is only one possible way that that can happen. How many total outcome? Well, we found out that there was 72. So what's the probability that they're going to be exactly what they wanted? 1 out of 72. Okay, so in this situation, we had to use a permutation in order to set up a probability. Okay, so go ahead and try that with guided practice 5. Okay, we are choosing 4 of 12 members, and since we are just choosing, we're not making them president, vice president, and so on, we're going to use a combination. So there are 495 ways to choose those 4 out of 12. We want 4 friends to be selected at once. So the outcome that all 4 of them are selected is just one. There is only one way that those 4 are randomly selected, and that's 1 out of the 495 ways of combinations. So just remember, biggest thing is understanding the difference between a permutation and a combination. When does arrangement matter, order matter, and when are we just choosing? And I think you're ready for the assignment for this section.